LeetCoders, and welcome back into a new LeetCode challenge, the word subsets. This is a medium level challenge. In this problem, we are given two lists of words, words 1, also words 2. Our task is to find all words in the words 1 that are universal for words 2. What do we mean when we say that a word is universal? The word, let's take Amazon. We should find all the words in words 2 on the second list, should be subsets from this word. So let's take Amazon. Do we have E? No. Do we have O? Yes, but we do not have E, so Amazon is not a universal. Let's take Apple. Do we have E? Yes. Do we have O? No, so Apple also not universal. Let's take Facebook. Do we have E? Yes. Do we have O? Yes. So Facebook is a universal. Let's take Google. Do we have E in Google? Yes, we have E. Do we have O? Yes, we have O in Google, so Google is a universal word. Take LeetCode. Do we have E in LeetCode? Yes. Do we have O? Yes. Okay, but this example is not enough because let's take our sentence. It says that a string B is a subset of a string A if every letter N P occurs in A including multiplicity. Including what? Multiplicity. So we should find the maximum frequency for each character in words 2. What I mean by this? Let's take this example. We have warrior. This we want to check if this word is universal or not, and we should find if WRR is a subset from the subset of warrior to check if warrior is a universal or not. Do we have W? Yes, we have W. And we should find two R's. Do we have two R's? Yes, we have two R's. Okay, if we take word, it's not a universal word because do we have W? Yes. Do we have R? Yes. Do we have the second R? No, we do not have another R in word, so word is not a universal on WRR. So guys, let's take this example, but let's add another E here. So we have these three words, Facebook, Google, and beetroot. I want to find if these words are universal of words 2 or not. Okay, I want to find if there is E's in Facebook. Let's take Facebook. I should find if there is two E's. We do not have two E's, we have just one. Do we have two O's? Yes, but we do not have the second E, so Facebook not universal. Google, we do not have two E's also, so Google not universal, but in beetroot we have two E's and two O's, so beetroot is universal. But let's add another E here. Let's take E, okay, and one O here. No, this is E. Okay, now one of you can think that we should find the three E's in a word and the three O's in this word, but this is not right. We should find the maximum frequency from the word. What I mean that we have to make let's take this, change the color to red. Okay, we should create a map for the maximum frequency in these words too. Okay, we have character, we have max frequency, max F, maximum frequency there. Okay, I found, okay, let's take this word. We have two E's and one O, so E have frequency of 2 and O have a frequency of 1. So we are iterating over this words 2 list. Now we finish this. Let's go to this. We have how many times we have O? We have 2. So let's take the maximum. We have 2 here and we have 1. So this will be 2. Move this into 2. And um, okay, we have E. Okay, this is 1E, and we have 2E frequency here. So what is the maximum, 1 or 2? Okay, it is 2. So this is the first step in our solution. To make a hash table, we have to make an ordered map to find the maximum frequency we have to get from these words. So you see what I did to find this map. Now, after we find this map, we should find two E's and two O's. Um, okay, the solution is about make another map for each word. So let's take um, let's take this beetroot. Okay, let's take the character E. No, it is the character C. Okay, and the frequency. We do not have to find maximum frequency here. We should find the frequency in a word. We will make this map for each word. Okay, guys. So we have B. How many times we saw B here? 1. We have E. 2. How many times we have T? Also 2. How many times we have R? 1. How many times we have O? 2. So when I found this map for this word, I should check if the frequency of the character is less or equal the maximum is more or equal the maximum frequency there. Okay, we do not have B here. We have E. Is E the frequency of E in this word more or equal the maximum frequency? It's equal, so we keep iterate. So T, we do not have T. R, we do not have T in this table. O, we have O in this table. Is the frequency of O in this word equal or more than the less than uh, more or equal the maximum frequency we should have? It is equal. So we have all these. We found E and we have O with the maximum frequencies. So beetroot should be a universal word of these words too. Okay, let's take Facebook. If we make for Facebook C and F. Okay, we have F1, we have A with 1, we have C1, we have E1, we have P1, we have O2, finally we have K1. Okay, now I should start check. F, we do not have F here. A, we do not have A. C, no C. E, is the frequency of E more or equal the maximum frequency? It is less. 1 less than 2. So we will not keep iterate, and also Facebook not a universal. So we move into the second word, Google. And Google the same as Facebook. We do not have two E's inside it. So okay, E or more. If we have three E's or three O's, this is also be true, and the word should be universal. Okay, guys, this is about the problem. Now let's go and write the code. So guys, first thing I created a result array to return the output. Now we should find the maximum frequency from the words too. So first thing I should iterate over the words too. Auto. Okay, now I should create an unordered map to store the frequency. Okay, before this, I should created a maximum frequency map to store the maximum frequency over all this array. So unordered map. We should store car and integer, the car and its frequency, a max frequency. Okay, and Now we should create a temporary map to store the frequency inside each one of these character, inside one word. So unordered. Okay, let's make it camel case. Okay, now inside this for loop we have a word, we have for example EEO. So I want to create another for loop to iterate over these characters. For auto C in word, okay, the frequency in word 2, I mean the value of this C should be plus plus, and after we find the frequency for this C, we should find the maximum frequency. So how to find the maximum frequency for auto? Okay, I iterated over this word. Okay, the max frequency of C equal max frequency of C, also the max frequency of C. We found the frequency inside the map over all these, and the temporary one we find when we check one word. So after that I found this is okay for checking these frequencies. Now let's go through each word and from words 1. Okay, for auto word and words 1. Okay, in this I should make one map for each word as we say. So unordered car and its frequency, let's say frequency in word 1. Okay, now when we found the word, what we should do? When we found a word, we should let's create a boolean variable, accepted, check if the word accepted or not, and let's make it true initially, because if the word is empty it should be a true, an accepted word. So let's dive into each character inside this word. So for auto C inside word, okay, what we have here, we should increase the frequency of C there. Okay, plus plus. Now we iterate over the characters inside a word and we find the frequencies inside this word. Okay, now let's go into another for loop to check auto C word, and now we want to check if the frequency we found in this word for this character is equal or more the maximum frequency we found in this map, in the max frequency map. So okay, if frequency in word 1 of C, okay, no, I want to iterate over the maximum frequency map. So let's say how to iterate over a map. Okay, C, and let's say required frequency we should find, and now the map we iterated over is max frequency. Max frequency. Okay, now if a frequency of C in word 1 less than the required frequency, we should return what we should return. We should make the accepted equal false. Also, we should break the loop, because no need to keep iterating over all characters, since we find one character is not happen. So now let's go out of this for loop and found if accepted, if not accepted, okay, no, if accepted, so return. No, we should push the word inside the result. So let's push back word. It's word. Okay, and so let's go out the for loop and return the result array and see what's happening. Okay, bismillah. Okay, how should we see this? Okay, it's accepted. Okay, great job. It's accepted. So guys, this problem is a medium level problem. The idea is to understand the problem very well. When you see the description of the problem, you can say just to find this, if these words are subsets of this word, without keeping in mind the frequency. So you will get unexpected error in the advanced test cases. So first thing, we find the maximum frequency for each character over all the words too. Then we made an ordered map for each word in words 1, and check if we have the minimum maximum frequency or not. If no, so the word is not universal, without keep iterating over the other elements or characters. And if the word accepted, we push it on the result array and return result. Okay, let's calculate the time complexity and space complexity for our solution. Here we have calculated the maximum frequency map, so the time complexity of this should be O of L, where L is the number of items inside words 2, because we are iterating over all the words inside result 2, words 2, and for this part, when we iterate over the words 1 array and then iterate over each word, so this will be O of let's say n is the length of words 1 array, multiply with let's say m is the average length of each word in this array. I mean the average length. So O of L plus O of n dot m. This is the time complexity. So guys, this is for the daily challenge on LeetCode. I hope I helped you in this solution. If you like my video, please like and subscribe to support me, and thank you for watching again, and see you later.